The last step in analyzing data from a graph is to write the equation of our best fit line. And if we look at this best fit line, it is definitely a linear relationship. So I want to write this equation in terms of y equals mx plus b. But I don't want to leave it in this generic form. I want to write it specifically for the data that we've collected. So the y here stands for the vertical axis, but I did not label this vertical axis the y-axis. I labeled it the force axis, and I used a variable of f. So for y, I want to use f instead. For m, the slope, I've calculated that. It's 115 newtons per meter. I carry the newtons per meter with the number. So I just put that in, 115 newtons per meter. X represents the variable that's on this horizontal axis. Again, I did not label this horizontal axis the x-axis. I labeled it the distance axis. So I do want to use that d as my variable. So instead of x, I put a d. And then I need to calculate this y-intercept. So to do that, I will use this equation and I'll use one of my coordinates. So instead of y, I'll use the y coordinate piece, 30 newtons, equals the slope, 115 newtons per meter, and then the x, 0.5 meters, plus b, and my goal is to calculate that b. So 115 times 0.5 is the 57.5, and then I need to move it over to the other side by subtracting. So 30 minus 57.5 is negative 27.5. If I think about that unit, I have meters times meters. These meters cancel out. And I'm left with newtons, and I'm subtracting newtons. So my unit on this number should be newtons. Negative 27.5 newtons. Whenever you get a number, it's probably good to think about it. Does it make sense? And so if we thought about extending this best fit line down, B is the y-intercept. That's where our line intercepts or connects with the vertical axis. So if you think about it down here, that is below the x-axis, which is in our negative quadrant. And so 27.5 seems like a reasonable value for what we would see here. And so then our last step in writing the equation of the line is to place this b y-intercept value up into our equation. And we've finished our equation of a line.